Hi, my stage. I'm glad to be here. Today, I'll talk about GitOps and will also touch on GitOps implementation in Asia. Let's take a look to agenda. Few words about myself and my experience. Then we will move to GitOps. Take a look. What is it? How it is working and how can we implement it in Asia? I started in IT more than 20 years ago, maybe correctly to say 25 years ago. The first step were IT administrator, PC repair, but time has passed. I got a different experience, worked as a developer, then moved to DevOps, and passed Microsoft certifications. In January, I received a nomination in the Microsoft trainee program. I also passed Oracle certification as a Java developer, CNCF as a Kubernetes administrator, and Kubernetes developer. I worked on different projects. One of the high-level projects was cybersecurity. But let's finish talking about me and come back to our theme. Okay, what is GitOps? GitOps is like an abbreviation of two words, Git as a GitHub version control system and Ops as an operation task. So, GitOps is a way of implementing continuous deployment for cloud-native application. It focuses on developer-centric experience when operating infrastructure by using tools developers are already familiar with, including Git and continuous deployment tools. I was wondering, does this abbreviation has its explanation in a clear format? And found that it clearly described and documented in www.gitops.tech. Please take a look at this slide. Kelsey Hightower says that we need to stop scripting and start shipping. It's really cool because productivity, first of all, depends on what we deliver for end user and how fast we do this. Also, we need to take note that enterprise companies' operations must follow many regulatory requirements, data privacy regulation, and security standards. Security should follow the principles of least privilege access. Audits need to track who changed what and when on all production systems. Does GitOps follow these principles? Yes. As I said, GitOps can be applied for the cloud-native applications, like Kubernetes. But Kubernetes isn't secure by default. So, how do we fix these problems? In a few words, Kubernetes separation. It is the answer. And now let's discuss the benefits that GitOps provide for us. Deploy faster. You could say it's part of, for example, Jenkins. I agree. But let's see what you are doing when deploying with Jenkins. First, you go to Jenkins web page, go to deploy pipeline, add some values that need to be present in deployment. There are three actions that you need to do. And in GitOps, what you need to do, only push your changes to repo. Easy and fast error recovery. For this, I can say, git revert. Do you know what's the separation for? And let's imagine if it is in a real Kubernetes cluster. You will need to remember that there are kubectl or helm commands. Also, your environment needs to be linked to Kubernetes. You need to remember in which namespace you deploy. A lot of things to remember. Or I am wrong. Easy credentials management. I already mentioned kubectl and helm. What do you need to connect to Kubernetes cluster? Yes, kubeconfig. So you need to get it, install these credentials files. As from my perspective, it looks like an SSH. Looks at kubectl as new SSH in DevOps world. So next benefits is self-documented deployment. GitOps first part of this abbreviation is Git. And what it means that all changes, all actions are written and documented to Git. If you need to create a new, for example, namespace, please write about it. New custom resource, please describe it and push this to Git. That's all, nothing more. Shared knowledge in teams. You store all environments description in Git. The DevOps team has permission to read from this Git repo. Looks like that it's what we need to share knowledge between team members. Each time that I did a new deployment of infrastructure, I also acted as a tech writer because I needed to describe what I did to set up this environment. With GitOps approach, all of processes are documented in a technical way because it's present in the VCS and team members can access it. I say Git so many times. Let me apologize. When I'm talking about Git, I'm talking about VCS, Version Control Systems. So it has a lot of benefits, but let's deep dive in GitOps. GitOps can be implemented in two different ways, push and pull base. Let's take a look at this diagram. What do you see there? That some applications Git repo is present. It holds an application code. After new changes appear in repo, some process is starting that produces a new container image. From the Azure side, you can use a trick. It is Azure Container Registry tasks. You ask me, what this task do? Task is a part of the Azure Container Registry that can get Docker file, container build instructions from repo and create a new image. In Azure, there are a lot of, let's say, helpers that can improve DevOps life. But let's continue with this diagram. The main idea here is two things, trigger and deploy. Trigger is a part of a process that adds changes or notify environment repo. And when new changes appear in the environment repo, it starts the deploy process. Next is a pull-based deployment. In this deployment, we also have an application repo and also has processes that are responsible for building and updating repo. But in this case, it's appear a new thing, operator. What is this operator? Operator observes the repository for changes, and if it appears, he updates deployment in Kubernetes. It continuously comparing the desired state in the environment repository with the actual state in deployed infrastructure. Whenever differences are noticed, the operator updates the infrastructure to match the environment repository. Additionally, the image registry can be monitored to find new version of images to deploy. So, the main and important difference of this approach is how it adds changes to the repository. And now GitOps in AKS. To describe this approach in Azure, I'll take an official Azure documentation. First, the single point of trust is the GitHub repository that holds the provisioned AKS cluster configuration. The repository stores all AKS application manifests and cluster infrastructure desired states. Every change to the cluster happens under version control. In this case, GitHub has such functionality. GitHub ensures review for the changes, prevent unintent or unauthorized changes, enforce desired quality checks. Second, Flux. Flux is a GitOps operator and controller, and it's the only component that can make changes to the cluster. Flux pulls cluster desired state changes from GitHub and syncs them into AKS. So, Flux. pulls desired change from the GitHub, detects any configuration drifts, reconciles the state in the Kubernetes cluster, manages gatekeeper and applications, update itself. Open Policy Agent Gatekeeper. He enforces policies with a validating admission webhook. Gatekeeper validates cluster configuration changes against provisioned policies and applies changes only if they comply with the policies. Sincere Security Tower. It is a GitOps control kit that provides an overview of all AKS clusters and helps manage policies. Sincere Tower is responsible for assembles all cluster images in an overview that shows which versions are deployed and identify outdated images. He provides feedback on policy violations via pull requests (PR), introduce risk acceptance whenever policies can't be applied for good reasons, provides security policies to Open Policy Agent Gatekeeper. GitOps in AKS consists of such things as AKS themselves, Azure Kubernetes Service. I will not describe what AKS is. I will only say that it is an Azure vision of Kubernetes. Then it is GitHub. It is a well-known solution that can store a codebase, like distributed version control system. Flux is an operator that is responsible for observing repositories and applying changes. Flux gave for such features. So, source configuration from Git, Helm repositories, and compatible buckets, as for example Minio. Customize and Helm support. Event-triggered and periodic reconciliations. Integration with Kubernetes role-based access controller. Health assessment for cluster and workloads. Dependency management for infrastructure and workloads. Alerting to external systems as a webhook senders. External events handling as webhook receivers. Automated container image updates to Git. It's doing image scanning and patching. Policy drive validations. Seamless integrations with VCS providers such as GitHub, GitLab, Bitbucket. Interoperability with workflow providers, GitHub Actions, as for example, or Argo CD. Interoperability with cluster IP, like CAPI providers. The next is Gatekeeper. Gatekeeper is a policy operator. As I mentioned previously, Kubernetes is not a secure solution. So Gatekeeper will take care about policy and its implementation in Kubernetes. Gatekeeper introduces the following functionality as an extensibility parameterized policy library, native Kubernetes custom resource definitions for installing the policy library, native Kubernetes custom resource definitions for extending the policy library, and also audit functionality. Last thing is Sincere Tower. As about the Sincere Tower, I will not describe it in all, but let me read what Friedrich Rapp, he is a Chief Information Security Officer at Raiffeisen Group, says. With Sincere Security Tower, our security teams get the insights they need into who changes what and when in our workloads. Information which would otherwise be buried in Git repository is now very easy to view. So it's like a viewer for the whole information that happens inside your GitOps process.
Good. So we mostly finished with GitOps and its component, And let's switch to Azure. In this slide, you can see part of Azure Cloud, Azure ARC. I think that it's abbreviation of architecture, but I'm not sure. Azure Arc, what it can do? It can do a lot of different stuff, but for now it is interesting for us because it can implement GitOps in connected Kubernetes cluster. In brief, Azure Arc is a complex solution that can operate in a hybrid environment, helping teams to manage not only Kubernetes cluster, but also virtual machines, databases, applications, solutions. Azure Arc offers simplified management, faster app development, and consistent Azure services. Easily organize, govern, and secure Windows and Linux servers, SQL Server, and Kubernetes cluster across data centers and multi-cloud environment in Azure. Also, architect, design, and build cloud-native apps, anywhere without sacrificing central visibility and control.
Key features of Azure Arc are: implement consistent inventory, management, governance, and security for your servers across your environment. Configure Azure Virtual Machine extensions to use Azure Management Services to monitor, secure, and update your servers. Manage and govern Kubernetes cluster at scale. Zero-touch compliance and configuration of your Kubernetes cluster using Azure Policy. Run Azure Data Servers on Azure Kubernetes environment as if it runs in Azure. Specifically, Azure SQL Managed Instance and Azure Database for PostgreSQL Hyperscale with benefits such as upgrades, updates, security, and monitoring. Use Elastic-Scale and apply updates without any application downtime, even without continuous connection to Azure. Create custom location on top of your Azure Arc-enabled Kubernetes cluster, using them as target location for deploying Azure Service instances, deploying your Azure Service Cluster extensions for Azure Arc-enabled data services, app services on Azure Arc, including Web, Function, Logic App, and Event Grid on Kubernetes. Unified experience viewing your Azure Arc-enabled resources, whether you are using the Azure Portal or Azure CLI or Azure PowerShell or Azure REST API.
In demo, I'll show you how to run GitOps inside the Azure. Before this demo, I already prepared several stuff for us. I prepared for us an Azure Container Registry. Here it is, MS Stage 2022. Inside this Azure Container Registry, as I previously mentioned, I created one repo. Here it is, this repo, sample MS Stage demo, and also inside the sample MS Stage demo, I already pushed one container. But as I told you, Microsoft has a lot of different tricks, and these tricks already I'm using them inside the Azure. So what I did here, I added one task. Here it is, here's my task. This task, go to my repo, this one, go inside this folder, read this Docker file, and create container based on these two Go files. This is a sample Go application which produced for us a one-page application with simple hello MS stage. Okay, how it's working? Let's see. It's already I already run it several times. It's run based on the commits and provide for us logs. You can get these logs from using this button logs, and you can see full scope of Docker container builds procedure. One interesting thing is that it also displays how this task is working and running. I put the sample of this task inside my repo, inside the ACR folder. Here it is, task YAML. And you can see that it's simply taking a new build with MS Stage demo latest, reading the file and building it from main folder. Then he running the push directive and push this container inside Azure Container Registry. So it's embedded task for the Azure Container Registry. Good. As you remember, separation of resource inside the Microsoft, one of the easiest way to do it is to create a resource group. So I created a resource group MS Stage, and inside this resource group I will create an Azure Kubernetes service. What I will do, I will go here, Kubernetes service, create. By the way, if you don't have a subscription inside Azure, please create it. You will have $100 United States for 1 year, and you can simply check how it's working, and you can create the same one deployment for you. So cluster name, let's just be MS Stage. Okay. I using, as you remember, my group was inside the Friends Central, so I will put my Kubernetes, the same one here, Friends Central. It's my demo, so I don't need high availability systems. I will disable all of this. Kubernetes version 1.21.7. Okay, let's leave it by default. Let's change size to the smallest one because it's demo. I will use B2. How much it costs? It costs $34. Okay, let's do manual. I think one will be enough for us. Next, node pools, agent pool. Okay, virtual nodes, I don't need them. Authentications will be system assigned, manage identity, it's okay. Role-based access control, okay. Active Directory, I don't need it, but as you see, you can manage your Kubernetes cluster based on the Azure Active Directory. Encryption and the rest. Okay, networking. I prefer to use Container Network Interface, CNI. Virtual network it will create for me. Subnets, yes. Service, okay. HTTP routing, I don't think that I will need them. And I prefer network policy based on the Azure integrations. It's interesting things because you can simply integrate your Azure Container Registry with your Kubernetes cluster. For this, you need to mention about these integrations in your Kubernetes service create wizard, and that's all. It will do all kind of the magic when it will be created this service. Container monitoring, it's demo. Let's disable it. Azure policy, enable. And advanced CSI, I don't think that I need them. Tagging, yeah, it's very wonderful and very useful things, because we can tag any kind of your cluster, and that's, for example, value true. This, for example, you will need to create some kind of query or something like this. Yeah, it will do it. Okay, yeah, it will be everywhere. Review and create, and right now he calculate changes that I did under my creation of this service. Create, and voila, it's initialized deployment and starting create my Kubernetes service. Deployment in a progress. So first of all, let's create VNet. VNet is the connectors between Azure Container Registry and my AKS cluster. And let's jump inside our resource group. Let's wait until it's created. From my previous experience, it will take me as 5 minutes. So let's back to my repository, and I'll show you what I want to create using the GitOps approach. Inside my GitHub repo, I want to create deployment. This deployment described in folder ms stage, and it's simple deployment, simple Kubernetes deployment. So, but one interesting thing, I want to create this deployment inside the namespace ms stage app. So first I will need to create this ms stage app, and then create deployment inside this ms stage app. As you can see, I'm creating deployment. This deployment is linking to my container inside the Azure Container Registry. It's using some scope of the resources. Container port 8080, the same one as I described in my code, and service with cluster IP. It is my deployment, but let's back to repo, and you will see that I already create a folder namespaces where I pushed description of my namespace. As you see, API version v1 namespace and this namespace name. Also, I labeled it with the same name. Okay, I think that it's clear. So what I will need to do inside my GitOps, it's first of all, it's need to go inside this folder namespace, create this namespace inside the AKS, and only after this it will need to create an MS stage app. Yeah, so let's check what's with our deployment. It's doing deployment in progress. It's creating container, so I think it will be created in few minutes. Yeah, it's already created this container, this cluster. Let's take a look to this cluster. So Azure inside the portal provide a big scope of interesting communication and interesting views of our cluster. First of all, we can take a look inside the namespaces that will be inside the cluster, workloads, it's called any kind of deployments, services and ingress, storage, and configurations, unlike config map, etc. Yeah, by default, Azure Kubernetes services support GitOps, and we can simply create GitOps configuration here, but let's do it with Azure Arc. It will be much more easy and much more comfortable for us, because it will we will do Azure Arc enabled with simple one command, and I'll show you how to do it. Okay, so inside the MS stage, what we see here, Deployment in progress. I think that it's still need like 1 or 2 minutes, maybe some less. But let's take a look at inside the resource group, when we creating an Kubernetes service, Azure also creates such things as virtual machine skill sets, network security groups, Azure managed identities, external public IP address, Kubernetes load balancer, and managed identity. One of them will be for the Azure policies, and second one will be for the agent pool, for the connection inside the agent pool. But let's see what we have inside our cluster. Wow, it's too long. Let's see operation details. What's it doing? It's duration 5 minutes. 5 minutes 3 seconds, so maybe some kind of delay on Azure side, but I'm not sure about this. Okay, next scope of the resources that we need to create GitOps connection, it's Azure Arc enabled Kubernetes service. Yeah, as you see, deployment succeeded and cluster is created. So let's create this Azure Arc enabled Kubernetes. Let's type ARC Kubernetes Azure Arc. Yeah. It will open a new wizard for us. It's some information that you will need to connect your Kubernetes cluster inside the Azure Arc. As you see, that version of your cluster need to be 1.13 or later. Ports 443 and 9418 need to be open. Also, this will generate for us an Azure CLI script. You will need to install the latest connected K8s extensions, and you will need to have a kubectl file with cluster admin permissions. So, okay, let's go there. Cluster name ms stage. Yep. Region will be France Central, and cluster it's not behind the proxy server. So okay, next will be the text. As you see, you can provide different texts there, and then it will provide for you such as this script for the Azure connections. Let's copy them and run. I prefer to use and build it Cloud Shell. Reconnecting, open new Cloud Shell. I think that you remember that we will need, first of all, have the Azure Kubernetes service kubectl file. So let's edit inside our Cloud Shell. AKS get credentials. Name of our cluster it's ms stage, and this group it's the same ms stage. Okay, merge ms stage as a current context inside my kubectl. Next step is to enable Azure Arc connected cluster. Let's run it. As you see, this operation may take some minutes for a while. Let's just wait. let's see that our Azure Arc Kubernetes cluster is enabled. So let's go to our MS stage. Let's do refresh. Here it is, our Azure Arc, and let's do GitOps. So push the button GitOps, create Flux version 2, configuration name, let it be MS stage, namespace MS stage. Scope, it's interesting things. If we want to do any changes inside whole of our cluster, we need to push this button, provide the configuration for the whole cluster. Or if we plan to work only inside one namespace, in this case we can leave namespace. Next, here it is, we need to add our repository. So copy, add them, branch, I'm using the master branch, I'm inside the public repo, sync interval, let it be 2 minutes. Next, and now we need to do some kind of the customization. As I told you, we have an application that installed and described inside the folder MS stage. The same one, interval, let's be 2 minutes. The trial interval will be the same as the sync interval. Prune, because we want to prune everything, and force our deployment. Save. And second one, customization, it's our namespace. So let's name it namespace. Configuration stored inside the folder namespaces. Let it be the same one, 2 minutes. Prune, force, and save. Voila. And now let's do some kind of the tricks, because first of all we need to create namespace and then apply our deployment inside this namespace. So let's go inside the application, depends on namespace, save. Next, review, let's check our configuration and create. Voila, it's running. What it's doing, it's go inside our repository, read all of the configurations that we described inside the MS stage folder and namespaces folder, and then apply this configuration inside our Kubernetes cluster. Okay, let's go to our Kubernetes cluster, namespaces, and let some wait, as it will take near 2 minutes. 2 minutes passed, and what we see that our GitOps Flux extensions and GitOps configuration was created successfully. And after the refreshing, we will see that our MS Stage app is present, and this namespace is present also. Let's jump inside the workloads, and let's see that inside the MS Stage app we have our deployment ARC K8s demo. Here it is. Our application is up and running. So that's probably all from my side. Thank you. If you have any other questions, please contact me.